Hello, I'm Sue Nelson, and thanks for joining me on the Create the Future podcast, brought to you by the Queen Elizabeth Prize for Engineering. Now, I like to think we're a topical podcast. In 1914, one of the greatest feats of engineering was officially opened. Its construction resulted in the biggest earth dam in the world at the time, as well as the creation of the largest man-made lake. And it allowed, for the first time, travel from the Atlantic Ocean to the Pacific via a 48-mile-long shipping route, instead of over 15,000 miles around the South American continent. This shipping route is, of course, the Panama Canal, and our guest, Ilya Marotta, has enjoyed a long career working on the canal and was chief engineer of the Panama Canal expansion project, which was completed in 2016. After becoming the Chief Operating Officer in February 2019, she's now taking up a new role as Deputy Administrator of the Panama Canal. Ilya, welcome to Create the Future.
Thank you. Happy to be here.
Now, you're from Panama. How were engineers treated in this country? Were they treated as gods because you had what has often been called the eighth wonder of the world?
Not really. Actually, engineering in Panama is not a very glamorous job. It's becoming glamorous.
Because of you.
I think the expansion program had a lot to do with it. So it's becoming more visual. And we're making an emphasis for kids and young adults to go for engineering and STEM.
And obviously the Panama Canal must play a huge part of that.
Of course, every kid wants to work in the Panama Canal. So we have not only engineers, we have a lot of different professions, but engineering is one of the driving forces.
Now, why was it difficult to connect one ocean to another? Because I suspect for many younger people listening, you just think, well, what's the big deal?
Well, the big deal is you have to go through a mountain range. So that's the main reason the original plan from the French to build a sea level canal failed. Because the Panama Canal is basically a water elevator. You have to climb, go across the mountains, and go down on the other side.
And there's a 28-meter height difference between the two coasts as well.
Absolutely. The difference is not the coast. The sea level is pretty much the same on both oceans. But to get from one to the other, you do have to climb 28 meters worth of mountains.
So obviously you weren't there when the Panama Canal was actually originally built, but looking with your professional eyes, how do you view it now? Because it was quite a difficult job as well in terms of lots of illness at the time.
It was an amazing job. When you think that the engineers that designed that canal didn't have computers, didn't have all the technology we have today, and the way we operate the original canal is the way they designed it. We haven't changed anything because of a requirement of a change in technology as far as operationality, but we have changed a few things to enhance because there's so much new technology that can give us more information than before. But it's worked perfectly fine for 100 years, the way they designed it.
Now, you went to university in Texas in the United States. What made you study marine engineering?
Actually, it was by chance, and I'm really glad it happened. I was a marine biology major. I have gotten a Fulbright scholarship because I love scuba diving. That was my life. And after a year and a half, I went to Panama, so it wasn't a very promising job of what I wanted to do. So I wanted to be by the water. That was my main driving force. I want to be by the ocean. So I went for oceanography. That didn't work very well either. So I said, well, what else is there? Marine engineering. Design ships, repair ships. So that's how I ended up there. And my first job in the canal was in the Panama Canal shipyard, where I actually worked with ships. And it was I fell in love with my career when I started working.
Oh, that's interesting. So it was actually, I hate to use the word fate as someone with a science background, but it does feel like it all came together.
It came together in a very surprising way. I didn't know what to expect. I just needed to get a degree. My dad says, you have 4 years, get it done. And when I went to Panama, working in the shipyard was like amazing because you can feel how engineers create something in an office And I would walk out to the shop, see how it was being fabricated, and then I'll see it on board of the floating equipment. So it became like, wow, this is really amazing. How can you design something and then just see it built and then see it out there? The same happened with the expansion program. It was amazing to see something from paper to reality.
And I read somewhere that Jacques Cousteau, you mentioned you loved scuba diving, that he may have played a little influence there.
Oh, he was the biggest influence. He's the one that opened my eyes to the marine world, to the sea. And that's how I mean, I've loved the ocean. I've been going to the ocean since I was a little girl. My grandparents had the water by the sea. And I've always had this attraction to the sea. So because marine biology didn't work, marine engineering did.
And how did your early career progress at the Panama Canal?
Panama Canal is a big company. We have over 10,000 employees. We have water potable plants. We have power generation, the shipyard, a lot of different areas. So I basically started moving around in all of engineering disciplines. Once, because I lived in the Pacific side and I worked in the Atlantic. And after traveling 4.5 years, I said, let's see what else is there. So we have dredges because we have to maintain the navigational channel clear. I applied to a job in dredging division as an engineer, and I moved over, and that's kind of midways between the Atlantic and the Pacific. After a while, I put in for another job as a mechanical engineer because we have a lot of buildings, so we had to do air conditioning systems. We have fueling facilities for our tugboats and our launches, so I had to do some mechanical designs for fueling facilities. So I moved into that job, which was great. I also got a degree in engineering economics, so then I went to work for accounting, quite different, but it opened a new world. And it was basically to define investment projects versus maintenance projects. And then I went to operations, opened another new chapter in my life. And in 2002, when they decided to create a team to work on the Panama Canal master plan, which included the third set of locks project, then they called me up and they said, are you up to it? I said, of course. And from 2002 until 2016, I worked in the expansion program. Again, from concept to design to execution, and now operation, which is fantastic.
So let's go into a bit of a detail into that expansion project. What needed changing?
Basically, the original canal had, if we think of container vessels, had the capacity of putting a vessel that would carry 5,000 containers maximum. World shipping was increasing significantly in the world, and we would be relinquished to a local route if we didn't expand and allow bigger vessels. So we needed to make a new lane to allow big ships. Originally, we thought the biggest vessel would carry 12,000 containers. Today, we have put vessels that have had passed over 15,000 containers. So basically, we needed an additional lane that will increase our capacity, not only in number of ships, but most importantly in size. So we would continue to be a very important international maritime route.
Now, you mentioned it's a very big company, 10,000 employees. Only just over 1,000 of those are women. And I've noticed in photographs of you that you're often wearing a pink hard hat or a pink high-vis jacket. That's making quite a statement, isn't it?
It is. It's a female statement. And I did it mainly because when I got to lead the expansion program, I've heard that some people were a little bit reluctant that a woman could do the job. And that's when I decided, if you look at my pictures of first year, I'm wearing my regular standard white hard hat like everybody else. But when I've heard that some people were questioning the ability of a woman to run the project, I said, it's time to make a statement. So that's how the pink hard hat came to be.
Now, is it quite unusual for an engineer to be there from the beginning of a project right through the end of the project? Because it was so huge and you had to build an extra lock as well.
Well, 9 years, which was the execution of the project, is not a long time. One of the successes of the project was precisely that the people that started with the concept finished the project, because then you're so involved, you know the project so well, it's a lot easier to manage. And especially at the end, when you get contractor claims, you know that contract by heart, you know the project by heart. So I think it's a very good practice to have somebody from the beginning all the way to the end overseeing the project.
And did the people who were perhaps reluctant to see you take charge, probably a little bit of envy there, did they change their mind once the project was completed?
I sure hope so. I'm sure they did, because I never heard back from it. And I think, on the contrary, I think the fact that the project was successfully done kind of reassure that gender equality, that basically we have the same abilities to do the same types of jobs. So I think it was a pretty good message all around.
Now, there were some quite challenging technical issues in terms of making, doing the expansion project. I read a few that made my eyes go, what? But I'm going to hear from you first to see, just in case my one's not in it, what you felt were the most difficult parts of the job.
Okay. There were two kinds of difficulties. My motto was never a dull moment. There was something to resolve every day. I think people was one of the most complicated issues because everybody thinks differently. Everybody thinks they know best. Everybody wants to do things their way. And when you have a project of this magnitude, you have a lot of bright minds. So everybody's right, but you need to have uniformity and standardization. So you need to please everybody. Technically, we had quite a few issues. The biggest, let's say, issue we had, technically speaking, when we were doing one of the tests of the seals of the logs, testing one chamber full of water and the other chamber empty, which is never going to be a condition for operation or for maintenance, but we had to test it. We had some cracks through the concrete. We had water gushing out of the concrete, was not expected. And of course, the engineers went right away to see what happened, and it was a faulty design. They had not put enough steel rebar to secure the strength of the water over the lock gate. So that was fixed. Another huge challenge we had was we had to build a 2.3 kilometer dam. The foundation was quite fractured, so we had to do 3 to 5 times more grouting than we expected. So that project got delayed 2 years, but because we started it so early, it didn't impact significantly the end of the project. And then we have a labor stoppage, which was a contractual problem. And
you had everything, didn't you?
Yes, we had it all. It was
Never
really
a dull
scary.
moment. Yeah.
Never a dull moment. It was pretty frustrating because you always have problems in the office with the contractors, with the contract. But when you see the project moving forward, you're like, hey, we're having progress, even though we're having problems. Well, when they stopped the work for 2 weeks, there was no moving of the project and problems in the office. So that was scary. We had to sit down with the contractor, negotiate it for 3 months, even though they did go back to work after 2 weeks of negotiation. So we had it all. We have over 80 nationalities working in the project, over 200 contractors, different contractors. So it was a challenge, but with a very good team, and teamwork was what accomplished the goal.
Oh, it's incredible. And what's amazing as well is that in your answer, you didn't even include what for me, raised my eyebrows, was the fact that buried near the surface of places where you had to work, there were old US military bases with explosives.
Oh, yes.
Oh, now you remember, yeah?
I remember now. It's funny because as time goes, you tend to forget. Yes, one of the main things, and actually, this was my husband worked for the canal. He's retired now, captain on a dredge, and he came up with this suggestion that we use that land for disposal site. And he actually got an award from the CEO, from the administrator, for his idea, and we used it. We had over 500 hectares contaminated with explosives because there used to be a former U.S. military base, and that was a shooting range. So the idea was, hey, we cannot use this land because it's contaminated. Let's clear it out. Let's use this as a disposal site because it was right next to the works. We save a lot of money on hauling material far away, and then we can use that land afterwards. So we did. We cleared 1 meter of land, detonated whatever was found there, and then we used that as a disposal site, and now it's usable land.
Gosh, well, that's pretty incredible. So how is for you then? What was the most rewarding part of that job? Was it the people side or is it the engineering side?
It was both. And
do you know what? I knew you were going to say that.
It was both. Like everybody would say, wow, this is amazing, talking about the project, the engineering. And I thought, this is my everyday job. It really didn't seem that big of a deal until the first day I saw our testing ship come by. that day it was like a realization, like, wow, this is amazing, this is big. But people, working with so many people, I've I developed a lot of negotiating skills. I developed a lot of conciliatory ways of getting things to get done. I mentor a lot of people, so I grew a lot personally in my people skills. So I have to say they were both magnificent. I mean, I love being the gates being fabricated in Italy. That's like my favorite part of the whole project, how they were built, how they were transported, how they were installed. So it was a magnificent project all around.
As a child, did you provide hints of where you would end up? I know for a lot of engineers, they look back and they say, I was obsessively making things, taking things apart, putting them together, playing with Lego. I know you said this love of marine biology and everything scuba diving, but was there anything else that looking back you think, there were the seeds?
Not really. I was always good in math, but I love biology. So when I came to the realization that marine biology or oceanography wouldn't work, I said, my thinking was, well, I'm pretty good in math. Why not engineering? So it was like a second thought. But when I started working in engineering, it was like a whole new world opening my eyes. Just like Jacques Cousteau opened my eyes to the underwater world, my first job in the canal opened my eyes to, wow, engineering is really amazing. So it wasn't a driving force as I was a kid, but once I started working, I realized how underestimated engineering is and how on it's not glamorous, but it really is once you're in it. So I think people need to understand how amazing engineering is to solve the problems of the world, how we make life better for the human beings. Without engineers, that wouldn't be possible.
And how can we get more women into engineering? Because it's not just, your company, most companies around the world, women are in very much the minority.
I think there's so many engineerings, and you always hear about the traditional ones. So I think we start exposing the different types of engineering that could be maybe more appealing or more attractive to women, or once women understand how amazing it is to resolve, to be creative. It's innovation, you know?
I was just going to say the C word there. I think creativity is something that people often foolishly don't apply to engineering or science, and it is.
Of course, people think creativity is arts. It's not. It's art and more. To have a problem and to find the solution to a problem, you have to be creative. It's that simple. One thing is for art and another thing is for engineering. So I think that needs to be brought out. And like I was teaching this, I was giving a speech to these kids, young kids, 11 years old to 15-year-olds about engineering. And I was telling them, like, when a person gets injured and loses an arm, that prosthesis, it's made by an engineer. I was showing them the basic things that people don't think about, the chairs you're sitting in, the materials that things are made of, material engineering. There's so many engineerings, I think they need to be spread out so people understand and then they become attached to it.
How is your job going to change as Deputy Administrator?
I will be more in policy, more strategy, less doing. So I'm kind of looking forward to it because there's a lot of things I think can get better in the canal. I mean, we're doing good, but we can always do better. You can always do better. So it'll be nice to be able to impact beyond what I've been doing in the canal. So it will be more of that.
Now, you're in London because you're a judge of the Queen Elizabeth Prize for Engineering. What's it been like examining other people's engineering projects?
It's been mind-blowing. I had to study a lot. I had to learn a lot about things I didn't manage on a daily basis to be able to evaluate which was the ones that we thought could get the prize. So it was amazing. It opens your eyes to how much is happening in the world in different areas. GPS, who doesn't use GPS today? I mean, and you take things for granted. So to me, being a judge was amazing. I'm learning a lot. So it's a good interchange because we're so many judges from different countries, areas, and specialties that you grow. You definitely grow.
And isn't that that sort of sums up to me engineering as well, is that in the same way that you studied economics and did interest in marine biology and then do engineering, engineering often brings together different disciplines.
That's the beauty. And I was telling the kids last week, to build these locks, you had to have electrical engineers, electronic, civil, structural, environmental engineers, hydraulic engineers. Engineering is a profession that makes you work as a team because not one single solution needs just one kind of engineer.
Now, Forbes magazine, I'm going to embarrass you now, included you in its 50 most powerful women in Central America list. Do you want to be considered or thought of as an engineer, a female engineer, or as a powerful woman? Or all three?
I think a female engineer. If I can touch people's life to make them be a better professional, whether if it's an engineer or not, to me that's the most meaningful thing. But if I can have people look into engineering in a different way, that's a wow.
Ilya Marotta from the Panama Canal, thank you so much for joining me on the podcast. Do join me next month for another insight into the world of engineering in our Create the Future podcast.